The U.S. Navy has finally acknowledged that videos appearing to show UFOs flying through the air are real.
I think what's important is that we have identified some very, very interesting anomalous type of aircraft. Let's call them aircraft.
It's rotating.
Images of that rotating thing captured by U.S. Navy aircraft, sensors locking in on the target.
I think some people still look up.
Yeah.
And you can't help but wonder, with all these stars, we know enough to know that they're stars just like the sun, and they've seen the newspaper headlines, they're planets orbiting these stars, and if they're planets, how could you not wonder if there's life?
To try to answer a question as fundamental and controversial as "Are we alone?", it is important to approach from an objective and evidence-based angle. We have many tools available to do this, but the best tools we know sit in the world of mathematics. It makes sense then to begin investigating this question first with a probabilistic argument known as the Drake equation. The Drake equation is commonly used to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way galaxy. Note, galaxy, not universe. We will first be working under the assumption that extragalactic travel is not possible, but this will be touched on later in the video. Here, n equals the number of civilizations in our galaxy with which communication might be possible. R equals the average rate of star formation in our galaxy. F sub p equals the fraction of those stars which have planets. N sub e equals the fraction of those planets able to support life. F sub 1 is the fraction of those planets that actually develop life. F sub I is the fraction of those planets which develop life, which also develop intelligent life and civilizations. F sub c is the fraction of those intelligent civilizations which develop to the point of technological advancement, whereby they become detectable, and L is the length of time for which those civilizations release those detectable signals into space. The Drake equation is most commonly used to argue for an abundance of life in the galaxy, but this ignores the variability of the output n when different constants are used. One example of a solution of Drake's equation might be n equals 10 times 0.5 times 2 times 1 times 0.1 times 0.1 times 500, giving a result of n equals 50. However, this is with the assumption that f sub 1 equals 1, f sub I equals 0.1, and f sub c equals 0.1. Assumptions on these constants will always be flawed, because we only have a sample size of 1 to observe, the Earth. It is also trivial to input constants which produce a very low value for n. For example, n equals 10 times 0.5 times 2 times 0.01 times 0.01 times 0.1 times 500, for a result of 0.05. Here the only constants changed were f sub 1 to 0.01 and f sub I to 0.01. These simple changes output a result that suggests even the existence of humanity today was only through simple luck, and it is more common for there to be no communicating civilizations in the galaxy at all. While we started approaching this problem with an attempt to use mathematics and logic, we are not able to output results which can be backed up by evidence, and the results themselves vary significantly. So what other clues and evidence do we have? Or more specifically, what do we observe? Most inputs for the Drake equation estimate high probabilities for intelligent and contactable extraterrestrial life within our galaxy. However, our observations do not agree with this result. To date, we do not have solid evidence of contact from other intelligent civilizations. This is commonly known as the Fermi paradox. There have been many attempts to explain the Fermi paradox, and there are limitless potential reasons. Some of the more interesting ones are either great filters, for example, all intelligent life wipes itself out eventually through nuclear weapons or artificial intelligence. The jungle hypothesis, now this is my favourite, the idea that when a tiger stalks through the woods, all the animals go quiet. Perhaps there's a reason we don't hear anything. Perhaps there's a tiger in our woods. Inner space, the idea that following on from a technological singularity, rather than needing to explore external space, intelligent civilizations dive into a deep virtual reality where all their needs they could ever have are met, and the requirement for expansion and external contact are meaningless. The zoo hypothesis, or the uncontacted tribe hypothesis. So the idea that intelligent civilizations treat new intelligence as rare and worthy of study and worthy of respect and to be left alone. This would explain why we don't see anything, because it's deliberately managed that way. Regardless of all of those, the ease of which the Fermi paradox can be explained certainly does not rule out the possibility or probability of non-human intelligence in the galaxy. Indeed, there are many, many explanations which are not even covered in those examples. Perhaps the most compelling explanation for the Fermi paradox is usually agreed, especially among physicists, as simply the challenges of space and time and the universal laws of physics. Or to put it more simply, the universe is big, time is long, and going fast is hard. So it seems worth looking into that in a little bit more detail. One of the most obvious and supported explanations for the Fermi paradox is distance. As an example, the nearest star is 4.3 light years away. Now, for some perspective, this is approximately 25 trillion miles. Driving this distance at 70 miles an hour would take 40 million years. The fastest rocket today would take over 17,000 years. This may go some way towards an explanation for the contact aspect of the Fermi paradox, but a radio signal can cover that distance in 4.3 years. Why then don't we observe a galaxy full of radio chatter? There are a few reasons that detecting radio signals from other civilizations is unlikely, or maybe even impossible. Radio is a form of electromagnetic radiation, aka light. Intensity of all electromagnetic radiation follows the inverse square law. Specifically, over increasing distance, there is an exponential decrease in intensity. To put this in context, the SETI array could only detect Earth from a distance of only a few light years away. Beyond this, we fall into the noise of background radiation. Searching for specific frequencies and focusing on directional signals helps, but only so far. So the vast distances in space make the search for intelligent life challenging at best and impossible at worst. And those distances are protected by the limitation of the speed of light. Physics today has a well-proven law that the speed of light is a barrier which cannot be broken. The closer to light speed you are, the more energy needed to accelerate to a point of infinity. This can also be thought of as objects becoming heavier the closer to light speed they get. Without a solution to the limit of the speed of light, we may never know the answer to the question of are we alone. All of this has been under the assumption that we have no evidence for other intelligent life, and exploring some of the reasons why this may be the case. However, is it possible that we've observed intelligence and simply not noticed or not accepted it? Maybe the evidence has been right under our noses all along.